Hi there, this is lesson 7.4. We're going to be solving some polynomial equations in factored form. So what we're going to learn about is the zero product property, and then also we'll be factoring some polynomials with the GCF. All right, so what does this mean? Well, if a polynomial is in factored form when it's written as a product of factors, so here's our standard form, right? Descending order of the variables. But in factored form, we have it written as those binomials, right? The product of binomials. So when one side of the equation is a factored polynomial, like this, and the other side is equal to 0, we have what is known as the zero product property, and we use that to solve the equation. We call these solutions the roots, okay? So let's see what that means. The concept is, if the product of two real numbers is 0, then at least one of the numbers is 0. So if A and B are real numbers, and A times B is equal to 0, basically we have factor A equal to 0 or factor B equal to 0. One of the two has to be equal to 0. So when we see it written like this with the polynomials, we know that either 2x, like here, 2x times this x minus 4, well, either the 2x is equal to 0 or the x minus 4 is equal to 0, because that's how we would identify the two factors. You just solve for x. So the roots then become x is equal to 0 and x is equal to 4. All right, when they are both binomials, you just simply solve them. We would add 3 to both sides here. We would add 9 to both sides here. The two roots are 3 and 9. So let's give this a try. In this situation, we know that either x is equal to 0 or x plus 5 is equal to 0. So if x is equal to 0, it's already solved. If x plus 5 is equal to 0, we solve for x. We simply subtract the 5 from both sides. So we say the roots are x is equal to 0 and x is equal to negative 5. Okay? Looking at number 2. Two factors. We have a and we have a minus 12. One of those two has to be equal to 0. So either a is equal to 0 or a minus 12 is equal to 0. Then we would add 2 to both sides and get a is equal to 2. So we have the roots. A is equal to 0 and a is equal to 2. Okay, these would be the solutions or the roots of this equation. And then finally, we have 5p, right? So this is a factor, and p minus 2 is a factor, two different factors. So either 5p is equal to 0 or p minus 2 is equal to 0. And so when we divide both sides by 5, we get p is equal to 0 here, right? Because 5 times, what times 5 equals 0? And the only answer is 0. And then we would add 2 to both sides. So we'll get p is equal to 2. Those are our roots. Okay, when two or more roots of an equation are the same, it has repeated roots. Here, we're not going to have repeated roots because they're not the same, but here we can kind of see that pattern that we learned about in the last lesson. And we know that there are two factors that are equal to x minus 1. So it's the repeated root scenario. So here you have two binomials, either 2x plus 7 is equal to 0 or 2x minus 7. Note that on here, when you're solving, you're subtracting 7 from both sides, dividing by 2. Here, you're adding 7 and dividing by 2. So you have negative 7 over 2 and positive 7 over 2. Here, because these two binomials are exactly the same, right? You're solving and you get the repeated root of x is equal to 1, so you really only have to say x is equal to 1. You won't be listing 2. Here, there's 3 factors. You either have x plus 1 is equal to 0, x minus 3 equals 0, or x minus 2 is equal to 0 in order for the product of all 3 to be equal to 0. So the roots then become negative 1, 3, and 2. All right, moving right along. So let's go ahead and solve some of these. So we're going to have a repeated root because this expands to x minus 3, repeated factor. Therefore, it's either, so x minus 3 is equal to 0. And when you add 3 to both sides, you get x is equal to 3. So this is one of those repeated roots. All right. So for number 8, why don't you go ahead and solve number 8 and let me know what the roots of this equation are. Okay, and I'm going to move right ahead. So I'm going to circle that, pause the video to solve number 8. I'm going to move right along to number 9. Here, one of these two factors. So we either have 2t plus 8 equals 0 or 2t minus 8 equal to 0. So we would subtract 8 on both sides. So 2t is equal to negative 8, divide by 2, and then we get t is equal to negative 4. Here, adding 8 to both sides, dividing by 2 gives us t is equal to a positive 4. So the two roots are negative 4 and positive 4. Two possibilities. That would make, so this negative 4 here, when you substitute it in, makes this whole first polynomial, binomial, a 0 when that becomes your 0 factor. Or if t is equal to 4, this one is equal to 0. All right. For number 10, we have a repeated factor here. So we have the fact that even though there's 3 factors, only w plus 4 has to be written once. So either that is equal to 0 or w plus 1 is equal to 0. So w is equal to, and you'll notice that when there's no coefficient, it's really easy to just kind of write this down. Negative 4, negative 1, because you're taking the opposite basically to solve for w. Okay, we haven't seen one like this quite yet, or with 3 different ones, but same thing, either this g, right, or this binomial is equal to 0. So we have g is equal to 0, or 6 minus, ooh, that's sloppy, 3g is equal to 0, or 6 plus 3g is equal to 0. So if we subtract 6 here, negative 3g is equal to negative 6, divide by the negative 3, then we get g is equal to a positive 2. And then here, we get subtracting 6 from both sides. 3g is equal to 6. Oops, negative 6, sorry. So negative 6 divided by negative 3, g is equal to a negative 2. So our roots are going to be g is equal to 0, g is equal to 2, and g is equal to negative 2. Sometimes they just kind of summarize it and say g can be equal to 0 to negative 2. I'll leave that notation up to you. Understanding that it's kind of like an and or situation. So then the last one of these factors has to be equal to 0. So I will let you solve number 12 on your own and check your work. Okay, moving into the section where we're going to start factoring. To solve a polynomial equation using the zero product property, you may need to factor the polynomial first or write it as a product of other polynomials. Look for the greatest common factor of the terms of the polynomial. This is a monomial that divides evenly into each term. So if we're going to factor the greatest common factor out of 4x to the 4th and 24x cubed, we know that they are both divisible by the 4 and the 24th. 4 are both divisible by 4. And when you look at the exponents, the GCFS, what the heck? I don't even know. What does the S stand for? I don't know. The GCF would be x cubed. So we have to look at the exponent, and basically we're looking at the factor, which a factor is like a building block or a piece of it, and it's usually indicated two smaller pieces that join together in multiplication to become the product. So when we're looking at this, we want to look for the smallest exponent is usually the greatest common factor of the variable. So the greatest common factor is 4x cubed. Now, when you take that and you factor out, it's kind of like, here, let me show this. It's kind of like you're dividing this by 4x cubed and you're dividing this by 4x cubed. Oops, and simplifying. So the 4's become a 1, right? And then 4 minus 3, if you remember your exponent rules, we get an exponent of 1 for what's left. So we pull this out and we put it on the outside. This term comes to the outside because it's our GCF. And then we're dividing each term by 4x cubed. So the 24 divided by 4 is the 6. And then obviously x cubed divided by x cubed disappear, right? This has a degree of 0 because x becomes 0. It's a factor of 1. So meaning that if you redid this, right, this becomes the factored form right here. Okay, but if you distributed it back in, you could get that. All right. So we're going to give these a try. So we want to factor the polynomial. So we're going to look for between 6 and 3, the greatest common factor, which is 3. We're going to look between x squared and x, and we said that the lowest exponent becomes that. So what is left? If I take 6x squared and I divide it by a 3, I get 2. And x squared divided by x, and I get x. Oops, sorry. So I just said 2. Let's write that down. So 2x, right? Because 2x times 3x would be 6x squared. Then 3x divided by 3x is equal to 1. So this becomes my factored form. I've just divided out this 3x. Number 14, looking for the greatest common factor. So I first look at the numbers 4 and 20, and I see that the GCF of those two would be 4. Looking at the variable y to the 4th, y cubed, y to the cubed can be factored out. It's the lowest exponent. What's left? Well, if I take 4 divided by 4, I get 1. Y to the 4th divided by y cubed leaves me y. Then 20 divided by 4 is 5. And we're done because the y cubed comes out evenly. Okay. All right, why don't you do number 15? Go ahead and factor out the greatest common factor and rewrite it as a product of two polynomials or monomials, right? Factor out a monomial and, all right, so let's see. What would we factor out here for number 16? 2 and 7. Neither one of them have a factor of the other, so they don't have any common factors other than 1. Relatively prime there. So we have z to the 7th and z to the 6th. The lowest exponent is z to the 6th, so we can factor that out. So we get 7z plus 2 when we divide out the z to the 6th. Okay, here I can factor out, so 24 and 8 have a factor of 8, h cubed and h. So I'm going to factor out this entire 8h. So 24 divided by 8 is going to be 3. H cubed divided by h leaves h squared. And then because I divided it by itself, I'm factoring that out. I'm left with 1. Okay, so number 18. Why don't you go ahead and work out number 18? Factoring out the greatest common factor and then leaving behind what's left after you divide. All right, now we're going to start solving it. So if we have this right here, 2x squared plus 8x, this is a sum, this is a binomial. It's not the product or there's no two factors here, but we can change that. We can actually factor the 2x out, and then we can say, here's our factor. We have either 2x is equal to 0 or the x plus 4 is equal to 0. Same here. The only difference here is nothing is equal to 0. So the first step that we're going to have to do is subtract the 15n from both sides so that we can get this equation, then factor out a 3n, then either 3n equals 0 or 2n minus 5 equals 0. So we'll try some of those. All right, so this is written, and we want to, it's already an equation equal to 0. We just need to factor something out. So we have 6 and 1, so we obviously going to factor out the GCF of 1, and then k and k squared, so we can factor out a k. And so we're left with 6k plus 1 is equal to 0. So either k is equal to 0 or 6k plus 1 is equal to 0. And so if we subtract 1 here and then divide by 6, we get k is equal to a negative 1, 6. So we have k value equal to 0 or it's equal to negative 1, 6. All right, why don't you go ahead and solve number 20, and I'll work on number 21. So I'm looking at 4 and 52. 52 is a multiple of 4. So I can factor out a 4, and I can factor out a z squared or exponent of 1. I bring out the exponent of 1. So if I take 4 divided by 4, I'm left with 1. Z squared divided by z, I'm left with z. Then I have 52 divided by 4, which is 13, and z divided by z is 1, so 13, and this is equal to 0. So either 4z is equal to 0, or z plus 13 is equal to 0. So I have z is equal to 0, and I have z is equal to a negative 13, because I would be subtracting 13 both sides. Okay. Hopefully this is making a lot of sense for you. So here we do not have an equation, so I want to start by adding 72x on both sides. So I will rewrite my expression, plus 72x, and now make it equal to 0 so I can factor something out. Is 6 a factor of 72? It is. So 6x becomes my common factor. I'm left with x, and when I divide 72 divided by 6, I believe I get 12. And that's equal to 0. So either 6x is equal to 0 or x plus 12 is equal to 0. So x is equal to 0 or x is equal to a negative 12. All right. Why don't you go ahead and do number 23, and I'll move forward to number 24. So we'll subtract 21p from both sides. So 7p squared minus 21p is equal to 0, and then I can factor out 7p. So I'm left with p minus 3 is equal to 0. So 7p is equal to 0, or p minus 3 is equal to 0. Therefore, p is either equal to 0 or positive 3. I don't need the positive sign though, do I? Because I'd be adding 3 to both sides. Those would be considered to be the roots of the equation. All right, so if you have any other questions, please be sure to bring them to class, and we will be practicing these in the next set of activities.